Hello? Oh, I'm not I'm not present here. Let me let me get inside a little bit. Okay. Oh, I didn't bring the BGM with me, so I'll have to like take that from there. Um, yeah, for today we're hold on, paste reference. Okay, is the BGM playing? Yo. Oh, okay. Okay, so for today we follow up from whatever talk, which is unlisted now. If you can find the link, you can still watch it. But you, if you can't, I mean, if you don't have the link, you certainly can't. Okay, let's hold on. I see some anomaly. All right. Huh. Still have some. Okay. So we're following up with uh, from from yesterday's stream. I'm going to use the AI to animate myself without even rigging myself at all. And if you if you really want to know what is it, I mean, if you really want to make sure, hear me out. Look at this. Um, if you really want to like help me out, that I didn't actually use the picture, I will have to show this one to you. No, not this one. Oh, it can't show my, it can't show itself. Um, cancel. Yeah, it can't show itself, but what I can do is print screen and put it in Paint. Yep, and hold on. Yep. So here is here is the actual picture of this guy, of me, uh, working on this. So basically, I didn't finish my drawing, and it is PNG, as you can see here. As you can see here, my picture is PNG. So that's it. That's the proof that I'm not cheating. Yeah, and I can I can't cheat. I can't cheat because I don't have money. And hold on, what is? I have to check. What is this Hugging Face? So Hugging Face is AI community. So this paper is, it has to be, hold on, it's CVPR. Hmm. Okay, so this paper is not. I mean, the clip title is actually wrong because I call it Hugging Face, but the Hugging Face is in fact the community website, which means it's not the actual AI itself. Anyway, um, I'm going to transition. No, the studio mode actually counterintuitive for real-time streaming, but yeah. Okay, I forgot to bring I forgot to bring the background again. Oh, I didn't forgot. I didn't forgot to bring it. I forgot to turn it on. Okay, hold on. Okay. Now, what is this window capture? Right. Now we are not capturing this. We capturing a little bit more. No, wait. This one is backdrop. Hold on. Okay. Okay. So we are capturing this one. Do I need to like show you an address bar because nothing is unsafe? So yeah, maybe just let you see everything, right? I'll let you see the address bar. Hold on. Okay, about that. And yesterday we were talking about this one, and apparently I feel like I want to use it to animate myself because I don't have money to like ask for VTuber VTuber Baba Mama. So I'm sorry, you guys. I'm sorry for um those artists. Anyway, I will be showing my uh desktop instead because hold on. Okay. Uh, I'm not. I mean, this is actually pushing capability of the AI because you see all these examples. No one wears hat, and I'm wearing hood. Uh, that's going to be one point. Hold on, let me write it down. Uh, where's my pen though? Yeah, I'm not going to write it down on the screen because uh, writing down on paper makes. I mean, it gives you more screen. To be honest, it gives you more space to write down. Huh. Okay. Oh no. Hmm. I should have prepared for this. Why? Why didn't? I have like 9 pens. No, I have like 10 pens. on ready to be used. It's all in the package though. Okay. You know what? This song is not going to cut it. I'll just I'll just remove it and maybe add uh, some interesting some interesting music. Although it's not really interesting because um it's my old work, and it's not really that good. Where is it? Um, hmm. Yeah, let's use this lab BGM. Oh, oh, okay. It's actually very loud, right? I forgot about that. I didn't hear it because, um, of course, um, it's not looped. Hold on. Yep. Okay, this one is going to do it for me for a while. I actually want to like do something a little bit more exciting. Plan on that. Uh, so this one is tinted fly motion. Hold on, where is the original? The original post is oh, maybe I forgot it somewhere. The original post is this one. So last time we read the paper, which is PDF, and hold on, I actually have it on my PC right now. Okay, last time we read this paper, not actually read, but yeah, you see, it's already widely used for video conference, movie affecting, right? Rely on label data, only work for specific objects. Okay. Pre-train, pre-train key extractor, therefore the approach cannot be applied to objects without label data. Okay, so what is the abstract? Um, Unsupervised method without using prior knowledge. However, it remains significant challenge for current unsupervised method. And there's a large host gap between the objects in the source and driving images. In this paper, new end-to-end unsupervised motion transfer framework is supposed to overcome such issues. Firstly, we propose pin-place fly motion. Yeah. So basically, it is this one. This is this is pin-place fly motion, as you can see it's TPS. Alright. drinking milk. Hmm. The thing is, we are not required to know such things like this scary mathematical integration thing. This one is actually just like a square of sum, squared of sum, and yeah, I mean these two equations is the same thing because you know what? Integration and summation is basically the same symbol in two different fields. However, though, where is it? It can, mm, according to the transformation is obtained as follows. hmm Solving this equation. Huh. I mean, we don't need to know about these. We can just like uh, tune the variable. What is this? Admin background transformation. Huh. Occlusion mask. This is how you like think about things uh overlapping in 2D. Training losses. Yeah, training losses. Loss function is basically a function that tells the AI how to correct themselves. Hold on, I didn't know about foam. What is the foam? What is it? 26. 26. First order motion model for. Hold on. I think this is the first paper I read. Wait, this is Edge. Oh, this is Edge, definitely. Did I see my research right? Wrong. I was wrong. Sorry. Um, wait, what? Okay, that's better. I didn't put, I didn't put um the stinger on this one, so it didn't come up in very fancy mode. But I will do it later. Okay, now you guys can see what I see. Uh, I was reading this on Edge for quite a long time. Okay, let me recap. So basically, uh, previous method, previous method just like need to be labeled first before working. Yeah. Um, Therefore, this approach cannot be applied without labeled data. right? So the previous one that is used in uh, driving video to the static object in the source image, which is widely used for in video conferencing and movie effects. Okay, now wait. Uh, the challenge in unsupervised method. First, the motion representation is not flexible enough, making it difficult for the network to learn the large cost gap between the object in the source and the driving image during training. Um, you know what? I'm not going to do arm. I'm going to like use my face, so that's probably already done. Hold on. So does it basically mean uh I can just use this one? I mean it basically mean I can use this one. Hold up. Why is it so slow? It's so slow. I can't believe. Oh, because I'm streaming. That's why. And this is not foam. Okay. This is what I learned from nVidia back like I mean you see it's last year and it only needs like uh one picture, the first frame of the video feed to be clear and crisp. Then it transmits like this chunky picture, chunky video stream, and then it turns chunk it transfer the movement in chunky video stream into the static image. However, I don't know how did they do like the other side of the face. It's actually impossible because we human cannot think about it too, unless we like very imaginative. I mean, very creative, but which I mean most of us do. Anyway, back to this one. So this is thin plate. This thin plate affine transformation. Well, so I don't know how do they come up with this. Look, yeah, you could come up with the key point detector that's intuitive, but how do you come up with like thin plate? It's impossible, right? And then this is at one AI, and this is another AI. So yeah, actually, this one is motion predictor. This one is another. This one is one AI. So these are three AI because if I detect I mean, it could be AI. Um, yeah. So this is occlusion mask. It tells us how an object overlaps, and because it doesn't know where, because it doesn't know what behind them. So this is what they drew. I mean, they could like improve. Yeah, they could like improve. What? Okay. So they could like improve this background um, replacement by just like asking the source, the driving one. But the driving can be different, can be different source. So it's impossible. Like, look at this. This is the source image. This punk cat. Now the moving image is the upper one here at driving, and you see, um, there's no. I mean, the only similarity is that they are they conforms the same shape, and here kung fu dance. I mean, kung fu dance. The source is one image, though. I have to remind you that, and the driving one, it should have been a video, but just like that. So this ours means this paper. So the paper can make the source image to follow the driving video and produce the ours result like this too. The AI didn't imagine anything in this case. They just like detect the transformation and apply it to people. I mean to models. Um, I see a chat, so I'll look at it right now. คุณเซฟสวัสดีครับสวัสดีครับคุณภูฟ้า Hello ภูฟ้า we have never it's been so long, right? I don't know or you're already left or you're here, but I did mention that this one is English stream. Anyway, uh, and also this one is a research stream. So these scary mathematic equation, I'm going to explain it how I understand it. First of all, the equation one is field integration of uh, summation squared. That's it. I mean, field integration of summation squared. What is it? It actually means you add up. I mean, you add up points in space and square the result, and then you just map it. The field integration just means you map it to the matrix. just like that. It's not not that like anything. It's not that complicated. Now, because the integration is continuous, but we are working on computer which is not continuous, they like they choose an arbitrary number and generate the point, and you get point tk is the function of p. uh, what is ak? Hold on. Okay, the ak is this relation. Is, if I remember correctly, it's the notion of this is Cartesian. Yeah, this is Cartesian. Okay. Okay, so okay, we have 2 times 3 and 2 times 1, and summation plus. Can it actually be added up? What is S? The source image is, so S is the matrix of data. Okay. Now, okay, so P is XY transpose because we need column vector. We don't need row vector. No, actually, oh, this is row vector because, hold on. Key points of image. See, tx is key point of the image. X is the image x, and predict n for S and D. D is the driving image, right? Yeah, driving image. Hmm. Okay, so UR's radio basis function, which represents the influence of each key point on the pixel. Okay, so this one is the radius of the radius power of each key point. So the first equation is key point detector here, which returns these data points. This is just the representation, by the way, it's not the real data. And it takes this and applying transformation to get the colorful one. Okay, so they take these dots to the orange mesh, and they get other color meshes as the result of transformation or the result of movement, and then they take this and apply to the AI. We take this to get optical flow and multi-resolution occlusion mask actually. Then they use both of these combined to get the final image combined with the source. Okay. So basically they have to invent two tools here and use these two neural networks. I think it's symbol for transformation. It tables in and out like this, right image. Anyway, let's read next. So what is the fourth equation? The fourth equation is predict the affine is additionally okay. Predict an affine background transformation like to the model background motion. Okay. So this is the orange mesh. Okay. Now what is this? The model predicts k plus 1 contribution map. We use the k. Hold on. Now we'll combine the k plus 1 transformation k TBS transformation. Wait, where did k come up? Dense motion. Okay. The key point detector is yeah. This is as of key points to generate k TPS transformation. So key point detector is actually this TPS motion estimation, and BT motion detector is constant concatenation. Okay, that to estimate the parameters of the affine background transformation. Now do I have to feed the entire video before the AI could work? I mean, it's not real time, but we can feed like first 10, I mean, we can feed like windows of 10 frames into the AI just to make it work. Hold on. Okay, so it just lagged 10 frames because after the frame 10, it will be, I mean, the window moves frame by frame. It's not moving 10 frames, 10 frames. Or maybe just the optimization standpoint. But, yeah, I think we will have to like give it a motion. Dense motion network. The model is an hourglass network. Hourglass network, yeah, it's a transformation. It receives k TPS transformation from yeah EKP. EKP is this one, the key point. Hold on. Oh, where's my glass? My glasses. It's a blue light cutting glasses. It's not a prescription glasses. I don't need prescription glasses. And the Cuda is actually too large for me to read. It makes my eyes how do you call it? It hurts my eyes. Um yeah. Yeah. I will have to move my mouse over here. I'm sitting like I'm sitting like 3 feet from the screen right now. My face is like 3 feet from the screen, and I still think that the character text is actually larger than I can read. Alright. What is it? สวัสดีค่ะคุณช็อกโกแลตสวัสดีครับ Hello, chocolate sun. I don't think you can understand this one though. I mean, it's English stream. You can talk to me in Thai, and I will reply in Thai, and I will continue talking in English. Um, so I wish I could like uh play anime music because it's actually it makes me it serves me better. Or maybe I can just commission someone for that reason. Anyway, so the then is hourglass transformation. The optical flow will be estimated by combining k+1 transformation at the same time. The multi-degree resolution are predicted by different layers of decoded path to indicate missing regions of the graph feature. An impinging network is also an hourglass network graph feature map. Okay, so it basically said what I said when I show you this picture in 5 parts. First, um, the key point detector is detecting where it should be, I mean, where it should be looking, and then the BC detector just like map all the motion here to be like to be influenced by the key point detector. Oh, and you see this cross? This this cross means they are trying to like predict the difference. And you know what? The source is static. The driving is like a series of static pictures. Or you could say it's a video, meaning that the source is a constant here on the right lower right side. So the source is constant, meaning that uh, the driving, the affine transformation is the differential from the initial data. It's not the differential from the previous data. It's the differential from the initial data. So this AI must suffer from not remembering. Do you understand what I mean? I mean, yeah, I didn't expect anyone to understand what I'm saying. I'm just a Thai VTuber talking in English. Okay, so so we got key points here. We got the influence of each point, and then we calculate it's not then, it's parallel. So at the same time we predict the motion match. Hold on, what is the background? Okay, what is the affine? Actually, I didn't understand. Affine transformation is is a Euclidean geometry function. Okay, it's affinity. Okay, uh, now we'll combine a plus one transformation and one after transformation to approximate the mapping T. We use a plus transformation to wrap S. S is source, remember? Cascade the wrapped images and feed them into dense motion network. Oh, hold on, what does this mean? It does mean combine k plus 1. Wait, hold on. What is k plus 1? K plus 1 might be key. It has to be key. Yeah, the first mention of k plus 1 is over here. See, this is the first mention. Is k Cartesian n, which n is arbitrary number. Okay. Is Cartesian or cross? I think it's Cartesian. It's Cartesian multiplication. Cartesian multiplication. I mean Cartesian mapping. Okay, I see now. Same time, we estimate k set of points using key point detector, and that's how we get k. This is k, basically. Okay, so why does it have k plus 1? I mean, what is k plus 1? Where does plus 1 come from? I think plus 1 means here the cascade. So the k plus 1 is k and affine transformation, right? K plus 1 transformation. I mean, this is k plus 1 transformation, so it has k points down here, and k plus 1 is the affine combinator. So k plus 1 transformation is then to dense motion network. What do predict k plus 1 contribution map? Okay, so we feed it. We are here now. We are here at optical flow and op- occlusion map now. Oh, we're not at occlusion map yet, but we are at optical flow. The M tilde, M wave, or anything you could say. I'll say M tilde. M tilde K is an element of R. What is R though? Is it real number? Yeah, I like to believe that it's real number, but yeah, it's real number, definitely. Real number of H Cartesian of HW, I mean, it's height kun width kun multiply its height and width. Yeah, so this is just uh the value M is an element of uh value of the picture, where H can see its height and width. So M0 corresponds to TBT, which is calculated over here, which is the orange mesh. Okay. TBT contribution map that activated by softmax to make them sum to 1 at any pixel location. Wait, what? Oh, oh, it has to sum. It has to make grayscale mapping. What is it? ฝันดีนะครับคุณช็อกคุณช็อกโกแลตบอกฝันดีนะครับคุณช็อกโกแลตแหมมันคงจะยากน่าดูอะครับที่จะมาแบบว่านั่งดูผมทำรีเสิร์ชกันสดๆจริงๆผมกะจะเขียนโปรแกรมนะแต่ว่าคืนนี้ไม่น่าจะได้เขียนโปรแกรม so good night chocolate sun. I think uh I won't be I mean I don't think I'll be programming today. Oh, it's exponential. Hold on, what? Hold on, what is this word? Oh, softmax. Okay, so softmax is a logistic function that most of AI nowadays use. Yeah, this is the equation. It's a logistic function. What it is basically a fuzzy logic, but you file the edge off, so it moves, and it gives you from zero, no, from 0 to 1, which if you have two sides of this, I mean, if you have two of these curves opposing each other at like, I mean, at position the yeah yeah at at position 0, I think if you have that, you will get normal distribution bell curve. Yeah, I mean, if you know, if you already know, this is the equation. This is half equation of normal distribution bell curve. If you haven't noticed yet, and you see, it even use sigma, and this is Thai website. So yeah, well, basically it's just like uh, 0 and 1, or either like in quantum physics if you want to go that deep. But you know what? It just um, it's a statistic. Okay, so okay, so you can pre-compute the lower one because it's constant, as you can. Is it constant? Yeah, it's constant. The lower one is constant. No, the lower one is not constant. Oh yeah, it's constant. The lower one is constant because the z over here is actually a matrix. The the little z here is an element of this z set, which means yeah. So for each point, they find softmax point. The mk is value of mkp, mk of p is value of mk at p coordinate. So, so mk, if you remember, I mean, you need to have. Okay, I know now why people are genius. I'm sorry. I mean, why people could read um research paper and some people couldn't, because research paper requires you to have big brain, literally big brain. I mean, not that physically, but you need to have a lot of RAMs to read it. I can like remember a lot of aspects. I don't have to go back and look it up often. I just want to show you. Okay, so compute optical flow. Wow. M okay, M0 is the orange map, if you remember. TBT is also the orange map. So this one is the the controlling point on the controlling point that is controlling the mesh, and it adds up with. Okay, so this is um weighing weighing statistics, weight statistics. My hands. I think I have carpal tunnel problem. I mean, I use mouse a lot, although yeah. Oh, because when I type, I didn't use my right thumb. That's why. the approximate mapping is used to wrap the feature of math of S extracted by the encoder of painting, drop out for TPS and reconstruct the text. Drop out for TPS translucent. Hold on. Um, isn't this one 3.1.1? No, I mean 3.1.2 because the calculation is over here. We use KTPS transformation to approximate the motion, but only a few them may work for the estimated observable. At the early stage of training, their contribution maps have zero value at any pixel location. After softmax, and I have no contribution during the entire training. Therefore, the network can easily fall into local optimum. Okay, local optimum is like you think you reach the top, but there's another higher top way over there, away from you. Like you scaling, yeah, you you scale like a mountain, but you are but you can go to the top of the mountain, but you cannot go to the top of the world because the top of the world is, I think it's Alps. It's not, yeah. Which peak though? I don't remember. Well, if you measure from like sea level, uh, Everest is the Mount Everest peak. I think it's called White Snow Peak or something, and that's the highest from uh, sea level. But if you say highest from the base, uh, highest from the base, the Alps have another peak that is actually higher than Everest peak. And also, you if you also count underwater volcano, there's another peak, but it's like 100 feet above sea level, so nothing quite interesting about that. So drop out. Now let me see. Okay, so it's the 13. What's this? Improving neural network by preventing co-adaptation of feature detector. Okay. I'm not going to read that though. Specifically, the exponential term set to zero respectively with probability p softmax probability such that some of KTPS transformations do not work for estimating optical flow in mini batch training, and the terms not set to zero are divided by okay to ensure that the expectation of you could say that this one is cheating, but I don't know. It's how they work. Ensure the expectation of this summation of exponential terms drop out remain constant. Oh, hold on. So it tries to calculate when it's learning it tries to keep this summation constant because as I mentioned earlier, this term could become not constant for each image. I mean, it should be constant. So they just like uh, multiply p over here on the what is it called? Well, the lower one is denominator. Anyway, on they just multiply p probability to keep the lower one constant, and that's actually how backpropagation works. Bernoulli distribution. Okay, let bi obey probability. Okay, so mkp is not modified if k is 0, and it is modified by some probability divided by some constant divided by some inverse probability, where this matrix T exponential bi exponential. Yeah, so basically it's just saying that you add this probability, this uh hold up. How do you calculate that? They add okay, I'm bored with this. Yeah, with this rhythm. Yeah, hold up. I made it in MuseScore, so it's not it's not a good thing. I mean, it's not really good. I have another song. I didn't finish that song though. Song piece though. I have another piece. Oh no, not the Odyssey. Uh, based on the question. Yeah. Oh. I'm sorry. I'm sorry. There's no way that I can like change it before it turns up. Oh, there's a way. Sorry. Yeah, I like this one a lot. Oh, I'm not. I mean, I I got lost in this music. I mean, I'm the composer, so I know what it's telling, what story that it's telling. Oh, it's not looped. I forgot about that again. Do you believe me that this one is major scale? Yeah. And no, actually, I can't identify the scale of this piece, but yeah. What will be left? Okay, so they just modify the probability of the softmax by adding some. You know what? This is basic function of AI. It's called uh, regressive learning. Yeah, it's called regressive learning. It's just like modifying this the softmax term in order to make the AI become um, becomes plastic, and this is formula for that. Uh, oh, it adds this one too, so that's why this term cannot cancel this term. do you get BK? Is it computed somewhere? No, it's just like probability P at set 0 respectively. Okay, so basically BK is to keep everything in range of 0 and 1. Yeah. We actually don't have to read this in order to use the AI, but I'm crazy. I'm actually crazy. Um, dense motion network and hold up. I think I had a bigger one for this thing. Hold up. For the baseline. Okay, so this one is me cringing around. Nothing else. I want to adjust the EQ of this one. I want it to be denser. This piece though. We employ the hourglass architecture network to. Okay, by the way, this is hourglass architecture network. Can we? Oh, oh. Okay. Zoom out, and you see optical flow. So the optical flow is telling the picture how to move from source to the target. And what is B and D though? Graph, pixel-wise multiplication. Okay. Okay, we are not at this point at all. For the dense motion network in painting has been proven effective in various work in dense motion network estimate a single occlusion map. For the warp feature map to in-paint the missing region. Oh, that's how it is. However, many experiments have shown that the progress of feature map change its scale focus change with its scale. Low feature map on abstract pattern, while high scale feature maps are more concerned with detailed texture. I mean, this one is the window problem. It's not window problem. It's windowing problem. Because large scale feature map me uh you still didn't scale the what do you call con how do you what do you call it's called uh I forgot about the word. Hold on, where is the original one? Where is the Stormless made? It's this one. Okay, so when you're calculating with metric, you often in not do entire thing in the same time. You often do in groups of divided values, and that is windowing in networking, and the net the windowing, the size of the window doesn't change when you change the resolution, which means the higher resolution is going to focus on detailed things, definitely. But if you increase the window, if you resize the window by the scaling factor, it's going to be focusing on the same thing, which means, well, it means um, it means you don't actually doing anything. I mean, and a bigger window means lower performance across the board. If a okay, so single occlusion mask is used to mask out feature map of different scale. What it learns during training will be trade-off among focus of different scale feature map. Hence, we predict occlusion map of different resolution for each layer of the feature map. The what? Dense motion network will not only estimate the optical flow, but also predict the multi-resolution occlusion mask by using additional convolution. Yeah. This word I'm looking for. Convolution layer. Yeah. The convolution window. That's the word I'm looking for. I mean, windowing means you divide you work on bigger part than one element, but not the entire thing. Not the entire thing. Bigger convolution window tanks the performance, so they have to keep it low. Like N5 means just five of five sets of data is going to be processed at a time. Anything something like that. Convolution estimated optical flow and multi-resolution occlusion must fed together into impending network. And the impending network we use multi-scale features generate high quality image. Details are shown in figure 3. Figure 3. Oh, that's boxy thing with meshes and dots. We feed S into the. Okay, so basically what I told you before we started to read this one. Yeah. What you got a part? Okay. The wrap feature map is then masked using corresponding concatenated. Corresponding resolution is concatenated to the part where skip connection through residual block. The generated image is output at the final layer. Okay. Oh, by the way, the layer here um is this. This is one layer. So it's the layer of a neural network. So this is it. As you can see, it has deep in its name. So it's deep and it's neural network. So it's deep neural network, meaning that it does have the inner network more than one. It has input layer, it has internal layer. Yeah, it has. Okay, so the neural network is like you have input layer, which is actually how you want to convolve your data, and the inner layer, inner neuron, inner neurons layer. If you have one neuron, if you have one neuron layer, it will be a single layer neural network. Every input and every output connected to every neuron in the first layer. No, in single layer, and that is a symmetrical neural network. Now, if you add another layer, it's called multi-layer. And if you add a lot of layer, which is often more than 6, if you add more than 6 layers, it will become deep neural network. Now, if each layer has less neurons than the previous one, it's called uh, what is it called? It's called tapering or tapering or encoder, and if each layer has larger, has more neurons than the previous layer, it will call decoder. And together, uh, if you concatenate it together, it will be an hourglass deep neural network. And that thing is uh, what nVidia call a transformer AI. By the way, the output can be less than the input, but often they've set it to equals because, well, there's no reason not to. And when it when it's equal, there will be some neurons, some output neurons that don't even work. So they just cut it out, like how our brain think that unnecessary connection should be removed, and it will be removed permanently. I mean, in this case, but in in our brain, it's not. The cell will be removed permanently, but there will be sister cell that has the same memory and still connected to the network. It's just new pathway. Okay, so we are talking about training losses now. Um, oh, VGC9. What is it? Uh-huh. Construction loss between the okay. The VGC19. Is this Lagrangian? Yeah, it's definitely Lagrangian. Anyway, it's just like this is two nested for loop. I mean, it's it's intuitive. It's just like for sum of absolute, but the absolute is not what you think. I guess V is the ith layer of pre-trained VGC network. Oh, you see, there's they're talking about pre-trained, but yeah, doesn't matter. Hmm. So this is not how they calculate it. This equation 9 is not how they calculate in this paper. It's equation 10 with a similar calculation. The equivalent loss is also used to constrain the key point detector. Okay, so random nonlinear transformation. Random nonlinear transformation. Oh, because they're they're looking for losses. So random data generated. We use the random light form, and in addition, we design auxiliary loss function for the models, namely BC loss and wrap loss. Yeah, because they have a lot of modules, so they have to evaluate loss of every module and apply transformation model to background to model the background motion, and we made additional constraints in background motion predictor. more more accurate and stable. We cascade the order of S in the obtain matrix. Obtain alpha metric. Um, a dash a apostrophe. We expect two alpha transformation matrices to remain consistent. Yep, and the loss is how different it is. Wait, recascade them in reverse order to obtain the affine transformation matrix. Oh, okay. So they define the affine transformation matrix by properly doing it first, and then they reverse the order, which is equivalent um, to inverse multiplication of the, the original matrix. So basically, it means it needs to be undone by reversing the sequence, and if it's undone completely, it will return one, and this loss function will become zero. I mean, yeah. So this one just inserted variable, and I mean, in normal algebra, this loss function is just like expected to always be zero, but this is analysis algebra, so this loss is expected to be close to zero. And now the wrap, how do you calculate the wrap? An additional constraint is also designed for impending network. Hold on. So that so the equation 12 is used in two different losses called BG loss and wrap loss. Oh no, one loss. Okay. Now the wrap loss is fed into encoder of the impending network. The wrap encoder feature map of S are used to compute the loss with encoder feature map of E at each layer. Hold on. What does this mean? The wrap encoder feature map of S are used to compute wrap encoder feature maps of S. The source at each layer, where E is the ith layer of impending network. Encoder can encourage to estimate the output flow more reasonably, making the wrap feature map constantly. Oh, by the way, the reason they are using analysis algebra to even bother thinking about training losses. This is not optimization. This is how neural networks learn. I mean, how neural networks learn, they learn through loss function. They try to optimize loss function to zero. Optimize means minimize in this case. So they're trying to make these equation become zero. However, though, the summation, I mean, well, it's a wrap, so the wrap, and I still cannot imagine how they like wrap D into S. Hold up. Oh, okay. So they find feature of S and put it into D. I mean, they find feature of S and they put D onto it and call that a day. I mean, call that the perfect calculation. Yeah, the final loss is common loss of foam and MRR. It's VGC loss though. VGC loss and VGC equivalent. And yeah, you see, if you are if you are asked how many of this how many modules that this neural network is using, you just look at the sum the final loss function, and you see that first they have main loss, and then they have algorithm specific loss, and they have the input specific loss, the two input specific loss. Yeah. So this one basically for AIs uh, concatenate together to make a giant AI, and that's how engineering works. Though they actually science through making BT and RAP, no RAP, WAP, WAP, yeah WAP. Testing stage. Home has two modules, standard and reality. Learn mode use each frame directly to estimate motion, while the reality mode estimate the motion between first frame and replies to S. Oh. Estimates the motion between D and the first frame. Okay. Standard mode use each frame D and S directly to estimate motion. I think H264 does it better in that case. You know, this paper, I had this idea before, but I have never tried to program it until I have to read this paper. Standard model does not perform well when there's a large mismatch between identities. Animate a thin person according to the motion of the fat person. Okay, so that's where foam breaks. Foam, as we know, it's the NVIDIA's technology. The relative mode requires that the pose of D be similar to the pose of S. Oh, okay. MI poses a new model. Proposes new mode animation where uh, this entanglement, okay, this entanglement animation where this entanglement that use additional train network to predict the motion that should be supplied to us, and we use motion that should be supplied to us. S is source. Oh, S is source. D is driven. Oh, my brain. You know what? I confused those two. Anyway, it's cleared up. You're good. เล่นแคทกรีดพอออกมาแล้ว uh, so Rencat uh is one of my one of the facility member. He is one of the staff. Okay, so we have like two staff, so one of the staff, just another staff, right? Okay, suppose I'm not counting my stakeholder as staff. He's the stakeholder. He's not a staff. Um, and Abunai is like a magical thing. I don't know. I mean, this artificial life form in she lives in liquid pod. She lives in breathing pod. So yeah, she's not a staff, although she's the attendant. Anyway, uh, serving the shape of base post and post. Okay, yeah. Let me read it again. Okay, disentangle. Okay, and we use the mode for image generation. Okay, we train the shape and the pose and a pose encoder as in MR shape. With the shape encoder learns the shape of the key points of S, and the pose encoder learns the pose of D. Okay, and then the detector reconstruct key points. We use key points of two frames. These informations is irrelevant until you want to design data point to improve the model. But if you are going to work with example model, you don't have to know about anything. We use key points of two frames from video. Oh, they use just two frames to train the network where points of one frame are randomly deformed to simulate the pose of a different identity. This encourages struct before permission. Okay, so to design an AI, you have to tell them what to do by statistic functions. You know what? This is this is the equation that starts it off. The equation of key point. Yeah. So basically, if you can find key point and you have mesh around the input, and you say the key point has its strength, then the difference in key points will deform the mesh, which in this case is called thin plate. Thin plate. Okay. And it deforms thin plate, and that's what started this paper. The dense motion network, the impending network. These are like nothing. These are like already there before they start this paper. Okay, so experiment. These are algorithms. Oh, TED Talks mean I mean Tai Chi HD, Tai Chi, Tai Chi. Oh, it's Tai Chi. It's not Kung Fu. It's Tai Chi. Tai Chi HD. Well, Two Face and MonkeyNet comes before TED Talk and Walk the Lab. Yeah. No, what? Hold on, Walk the Lab. Oh, Walk the Lab actually comes first. Anyway, so the video reconstruction comparison with lower is better. Best result in both. Okay, so L is the loss function, of course. AKD was AKD. Okay, Vox Celeb, video of different celebrity, downloaded from YouTube, cropped to this resolution. Range, okay, so the length range from 64 to yeah, that number, that magical number of computing. Uh, okay, so why anyway? Vox Celeb is a data set, so hold on, it's public because it's downloaded from YouTube, so it's public. Yeah, and then Tai Chi HD, 26 Tai Chi. Oh, it's foam. Yeah, this one is foam. You know what? We actually need this this capability because we are the VTuber. We don't need that much. Oh, oh, it's wobbly. I mean, wobbliness is something that VTuber can go about it. What that talk? GIF? Yeah, I pronounce it GIF. You can you can debate on that. I just want to say I'm choosing to say GIF. Animating abstract object with deep motion transfer. Yeah, why not? Um, oh, oh. By the way, I forgot to mention the lysine. You are free to share the copy, redistribute material in any medium or format. And I'm sharing by reading it to you. You mix, transform, rebuild upon material for any purpose, even commercially. Yep, you must give appropriate credit. Um, yeah, I give appropriate credit because I give. I mean, I'm open. I'm opening the entire GitHub repository. I give out the link. Wait, I didn't put it in the description though. And I read the entire thing. Not through, but it's it's entire. Okay, so that with that, hold on. Authenticity. What is that? Okay. Oh, sorry. So basically, they show. Yeah, I didn't read it. I just read the data and articulate it. I mean, the data actually speaks on itself because this table is well formed. So they show this one to some people. This is the GPU they're using. It's GeForce RTX 3090, which at the time was like four times the the opening price. But because they are a researcher, they bought it directly from nVidia. I mean, they use the baseline, so it's not hard at all to get it because they just got it. I don't know. Don't believe me. I I'm not someone who you should believe. People were invited to judge. how many people? Okay, so the data is irrelevant now because they just people were invited to judge. They didn't specify how many. It could be three people, or it could be 200,000 people, which is wildly different in context of statistics. Um, redundant frame. Hmm. What is it? 28. 28 is motion represented one articulated animation. I think this is. Wait, why do they have to cite every word? See, maybe it's algorithm. Yeah, it's algorithm. It's like you hit find and replace, and you like put the link after everything you can find, and you just okay, because I mentioned this one over here, so I will replace it with this one, the same one, with credit, and it's just like, oh, you're looking for this one. We have 200 places where it is, and they just uh, linked. You see, there's a there's 28 everywhere, and every yeah, every single one is MR28, which means they definitely automate the credit. But that's a good thing. I just find it funny. Okay, ablation. Hold on, I don't know this one. Um, to treat arterial fibrillation. Um, um, okay. Investigates the performance of an AI system by removing certain components to understand the contribution of components to overall system. Hmm. Okay, so it's definitely ablation. It removes part of the AI itself, which in this case, um, um, oh, So they started with nothing, and then they add these, and MRAA is the baseline because well they want it to be the baseline. Then they put TPS in, and they drop the unused network, and then they improve the mask, and then the custom loss function of the BT and the custom loss function of the wrap, the warp. Why do I keep saying wrap? Potent, what potential negative societal impact. While most methods may be used to make fake videos for proofing, for spoofing, yeah, some detection software will be easily determine the authenticity of video by analyzing the color texture, yep, or using the depth information obtained through the proximity sensor, which cannot be simulated by 2D image generating methods. And our approach can create a new benchmark for face anti-proofing researchers. Well, of course, but I'm not using it for that. I mean, I find it fascinating. However, how do you use the proximity sensor? I mean, if you are analyzing videos, how do you use the information proximity sensor? Especially videos on YouTube is compressed. How on earth depth information is present in compressed file? I mean, there's a way to embed it, but I don't think ffmpeg will do that for you. You have to invent a new metadata entirely. So the proximity sensor is not an option, but the anti-spoofing from this method is actually better. And as I discussed, the missing information here is like it's impossible to retrieve because the driving video can be different from the source video or from the source image. They, what they should have done is add a parenthesis here and say driving parentheses video and source parentheses image or still image or still, that will work, and generated video like that. Everything will be like, well, it's not it's not like that every time because, well, generated one is picture, and the driving is also picture though, because look at it. Sorry, not look at it. I mean, the drive the this this picture, this diagram here of figure. Okay, this figure two means is trying to explain uh, what happen what happens in one frame. So driving video in this case is only one frame. The source is well static, and the generated is one frame. And that's it. And what we are interesting is this hot picture. This is potential. Okay, enough enough nerding around. Let's get to the point. Let's go to scene. Okay. Okay, let's talk a bit. The goal of this the goal of this lab is to let me control my model without me trying to do live 2D. Well, the the thing is, I actually came across like three services that do that for me. Adobe Animate could do that. Hold on, I see someone. คุณเลข3 Hi guys. Hi. Should I be translating your name into English though? Yeah, I'll do it because I want to do it. Number 3. Uh, Sir number 3, right? Or Sire? Anyway, m- I would say Master number 3. Okay, so hello. Uh, I've been reading like I've been reading research paper like 2.5 hours, and yeah, nothing is required. I just want to preempt you guys with preempt. I mean bombard. I mean I want to bombard you guys about how AI works and how mathematics works in AI. Let's recap. Let's recap a bit. Uh, Here, I think I have to add like a whoosh sound. Yeah, a whoosh sound effect. That would be perfect. Oh, it's over here. No, it's not over there. It's over here. And this edge again. Okay. Hold on. Edge can open it like immediately. Wait, wait. Why? Hold on. This is hilarious. You see, I downloaded it, and when I click it, Edge, being smart as it is, knows that I want to open the local file. But if I click right click on Google Chrome, it actually goes to the URL on the top left corner, and it loads this one again. Why? I mean I have it in my computer. Anyway. Oh, that's oh. Anyway, yeah. So go back to the AI. Um, First of all, we have softmax, which is this this graph, and if you look at the generalized equation, this one is actually just one half of the bell curve, normal distribution bell curve. Yes, it's that thing from statistics that's still haunting you for like millennia. Yeah, and if you have two halves of them opposing each other, uh, um, half round, half wavelength phase different, it will become bell curve, like, yeah, like this. Yeah, sigmoid. Yeah, I mean, if you have two opposing two opposing softmax, you will get sigmoid, and the sigmoid is actually normal distribution. By the way, these are all uh, e- valid functions for machine learning. Sigmoid, uh, tan hyperbolic, yeah, hyperbolic tan. What is ReLU though? Oh, okay, it's just like um on and off. Okay, so soft plus. Well, yeah, it's sigmoid, but it like yeah, it accumulates. And Gaussian is, well, the odd one out, right? Gaussian, I've read that somewhere, but anyway, um, just that I didn't find the use of it for quite a long time, so maybe not. Yeah, I mean, Gaussian is good for like uh latent latent space, and yeah, latent space is AI, and aerodynamic calculation in Lagrangian space. Yeah. Okay, so you got you got the distance function, sum squared, and you got the wrapping function, which is which is uh which is you're looking for the point, and you're looking for the radius strength, and then you wrap everything with this thing, and then you find the regression, the AI regression metric, which is, well, oh, sorry, well, is softmax. Yeah, this one is softmax, the same equation that you saw earlier, and yeah, you just like take soft take the mapping from softmax again. The the picture looks like this though, and because you want to optimize it, you like uh, try to keep the deno- denominator to be uh, constant. You drop out some information that is, yeah, that that you don't like. hold on. This one is actually matrix decomposed. Yeah, I didn't. I mean, it's it's familiar, and I just, yeah. This one is. I just noticed that. Yeah, I just couldn't confirm back then, but now I could confirm that the dropout is actually the dropout optimization is actually matrix decomposed. Is literally matrix decomposed. And now the AI calculate all of these. They have to check their falseness, their truthness by loss function. If loss function becomes zero, that means it didn't do any work. It's just cheating because loss loss at zero means it it conforms to the reference. It completely the same as the different as the the reference, and they have for loss function as you can see in the equation 14. They have the base loss function from previous AIs that they are inspired of, or maybe just like anyway. Uh, on the on the equation 9. Now the equation 10 is the loss when they are trying to detect the key point. The key point means the point where they think is important in for the motion, like this. You see, it actually mirrors the motion, and it's the first equation though. And then they have the composition. The, they have the decomposed loss. The decomposed loss. I mean, they have what do they call? Uh, background loss. Yeah. Because they are trying to wrap things with background with background matches. They have to find a way to check that it's false or not. I mean, not it's false, not how falsy it is. And they do it with like they they arrange everything and then calculate the mesh, and then they rearrange it. I mean, they flipped it in see it recascade in reverse order. So the resulted mesh will be inverse inverse multiplication of the matrix, which means if they take matrix multiplication, uh, it has to be identity, and the identity minus identity should be zero. Now they also have warp warping when they finish, so they have that loss equation too. Um, well, I cannot explain this one though. I don't quite understand. Uh, so then the testing out. Anyway, I'm not talking about test because I didn't read it actually. Of course, I read it. Um, okay, now go back to hold on. Um, I forgot where I put that thing. Oh, oh, yep. Okay. So first of all, the code is on the GitHub, which is which is here, and it will link here. And there are several ways to download from GitHub. If you have GitHub account signed in, which I don't, you can just copy this HTTPS and I mean I mean I can do. Oh, um, hold on. Um, hold on. Uh, I I think it didn't do really. Are are you serious? Hold on. I mean I know that it's not CD in DOS, but what literal part? Okay, so it's CD like this, and hold up. Uh, how how do you how do you use it? Yeah, you don't have. Oh, PowerShell and command prompt is not the same thing. So you have to learn to use it. Okay, I cannot list this. I don't know. Maybe they can find it for me. Okay, they can't find it for me. Okay. Hmm. I think. Mm, okay, I'll do this for you. What what is SLS? Select string command. Oh, so it's grep. Um. Hmm. Okay, so there's nothing here. This is how you copy one. I mean, I logged into Git on my console so I can use it. Or alternatively, you see there's a zip file here. You can do that. But since I have two versions of them, so um no CD no ls cd and see now if you have Visual Studio Code installed, you just use code and what and space dot, and I trust this one. Now you can participate, but I don't want to participate unless I have to. Okay. Okay, now one thing, yeah, one thing to train, you need data set, and my computer doesn't have space for that, so I'll just straight up use pre-trained model. Oh, I'll have pip install first. So control and tilde to get console going. Pip install requirement. No, there's no S. Requirement. Does it have that? Okay, it does have. Oh, the I is missing. Metadata generation failed. Why? Python set up high 8 input did not run successfully to output. What is it? If this platform Win32 use Microsoft Visual VS Visual C, which doesn't have, I'll have to take this one to the real console. Pip install requirement text. Same one. How do I how do I get it? Okay, so it's outdated or installed improperly. And how do you fix it then? Check your pip setup to install version. Hold on a minute. Do I need admin control? Yep, I think. Um, D and it's data and document and I think it's project and AI. Yeah. Okay, it's definitely pip. I just recently installed it. What are you talking about? Python 3 M pip 3. Wait, um, okay. There's no pip 3. Yes. Or is satisfied? I mean, I'm running as admin. There's no setup tools. Oh, hold up. There's no setup tool. What the fuck? Okay, so pip setup, pip install, setup tool, already specified. Wait, what? 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 This is very strange. Why is my Python doing? It's outdated. Well, because it's Windows. So how do I actually upgrade? What easy setup module? Yeah, I'll try. Wait, what? Underscore setup. Yeah, it's missing. Now, can I do it yet? Okay, it doesn't work. How many L? Two. Okay. That was unroll, right? I think it's like. Wait, what is it? Yeah, the module is outdated. It is definitely outdated because, well, what do you call it? App? Yeah, Microsoft Store. Okay, so the Python doesn't work because I'm installing here from here. Hold on, there's Python 10 already? Shit. Oh, there's already Python 10. Um, hmm. And I have Python 2.7. Yeah, it's Python 2.7. Um, I don't know. Hold up, hold up. What is this? SSL required. Wait, hold up. It, it is why it's this why it exists. What does not exist is the SSL. Importer. What? Easy setup. Um, uh, what? Hold on. So it's working now? No. What happened again? Okay, so easy setup is gone. Now it's just um. Hold on. I'm using Visual. Wait, what? Visual Studio? Why? I have it on my PC though. Let's try that again. And goes to the. Oh. Okay, so I have to install Visual C++ 14 in Greta. Um, I only have like Visual Studio 9 and like um and the Visual C++. I think I didn't even install it. Um, I think yeah, I didn't even install this one. See, and which version is it? Oh no, it doesn't tell me. MSCV 14.2, which is yeah, it's 14.0. Um, okay, I need this. I don't think it could. Yeah, 5 gigs. You know, it's not gonna work. See, my PC doesn't have. Can I stop? Can I move it to other part? I need 5 gigs and oh oh hold on. Why can't I change? Um. hmm. Okay. I think that concludes the lab for today because I cannot get it working. Um. I mean, I know how to get it working by just like install the individual one, but this individual, however, though, look at this. This individual needs to be like installed in the C drive. Oh, it's just 14 meg. Oh, hmm. uh, all right. I don't think I need more than this. I didn't. Yeah, I didn't look at it. Oh, it's Enterprise 22. Wait, Enterprise. Enterprise is not free, right? See, it's trial edition. I often use community, but I mean, code is okay. Code is actually more used more often. Okay, it should work now. No, I mean it don't need this. I mean, it's still 2 gigs, and I can't even change the location. Uh, uh, and the installation don't even let me choose where to want to install it. Uh, okay, uninstall. Uh, do you have C++? Yes. Is it just linked or development environment? See, it does not compile C++. Uh, continue, load, close. Yeah, yeah. Whatever. Mm, yeah, I'll just use the. I'll just use this one. It's still 2 gig, and okay, I can just change this one to like everywhere, anywhere I want. Where is it though? It must be, yeah, drive B. No, don't keep. That should work now. Okay, so the lab isn't concluded yet, but I think it will be concluded soon, I believe. The build tool is 2 gigs. How is that? Oh, because I don't know, because the all the Windows component. I mean, CMake is like 90 megabyte, which is very low compared. I mean, very small compared to 2 gig. It's like 200 times different. So if I uninstall Visual Studio, I can reinstall it anywhere else. That saves me a lot of spaces. Okay, that's a good thing to know. Do I have the same problem? Looks like so. Hey, I have. I have C++ build. Hey, Visual C++ 17. What? Mm, oh, I have C++. Oh, hold on. I need to have Visual C++, but it's MSVC. See, it's Visual. How on earth? Wait, do I need this? This is alternative, right? It's SDK. Hold on. Um, going to be. And I think this is how a programmer read books, and I'm choosing the Bitcoin standard here because I, I literally have like 20 pages to go through. 8, 30. Yeah, I have like 30 pages to go through until I finish the book. Yeah, at this moment I should be talking, right? But I don't know what to talk. It's just like nothing, nothing to talk about. Do I have to talk about? I mean, can I talk about um this music? I mean, I want to, I want to compose a new one, but heck, my internet is actually not that bad. What is bad is my, yeah, it's my computer though. Uninstalling on hard drive now. It notebook, so I mean it's a laptop, so it's 5,400 RPM. I guess it's it's the beauty blue. So yeah, that's guesstimate might be true. Mm. I am reading the Bitcoin Standard book because I'm going to talk about it, but in Thai, not in English. I think there's a lot of resources in English, so I'll just do this. So my English content will be actually I want them to reflect each other, Thai and English content, but um if I'm doing that, I have like half productivity of other VTubers, while I mean I have full productivity while I have like half value. I don't know. I think I mean I'll bridge the gap with my grand plan, which I'm satisfied. I mean I'm 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 planning to teach you guys Thai lesson too, but the format, I don't think I can find the right format that I'm going to teach you with. However, I think because you guys don't know Thai language, that's why I am going to teach from the ground up. And the ground up, I yeah, I'm looking for something different for ground up Thai language. Anyway, I'll talk about. Oh, I'll be talking about financials and bitcoins and stuff soon. It might be in Thai entirely and just exclusive for Thai, but I don't know. I might want to do English version someday. I don't think it's going to work. Oh, it's working. Okay, that pissed me off. And that actually gives me inspiration. Like I can move my old school Visual Studio community. I should have changed it to 2022 right now. I shouldn't put it there. Enterprise. Yeah, community. Uh, how about if I update it? Is it come Visual Studio Community 2022? I don't know about you guys from overseas, but this is Thai internet. Is internet in Thailand? I mean, I reached 100 megabytes per second sometimes via Wi-Fi. Oh, okay, so what is it? Unexpected keyword argument ENV. Of course, because um we don't have ENV in GNU compiler. Oh, num. Oh, I have to wait for NumPy. Oh, or maybe I could just like downgrade Python. Oh, hold on. NumPy. Yep, it's equals to um. mm, can you use better version of NumPy? I don't know. I don't know. Can I NumPy Python? Yeah. Is that okay? So, Python requirement, pip requirement file. Can I specify larger or equal to, I mean greater than? Yeah, definitely. I think I will try. I mean, it's conventional to use this. The problem, the problem about using NumPy, using the greater sign is that, especially with NumPy package, is that NumPy is working with buffers and raw array in Python, which means sometimes they changed it. But I mean, 1.23 is not going to be different from 1.20, right? Wait, hold on. It's going to be a break. Yeah, it's going to be breaking change. Anyway, we'll try. I'll try. If there's an error, we'll just have to fix it. If there's 10,000 lines of code that's not going to work together, well, um, hmm, where is this requirement from? Panda. Hold up. What are you doing, Panda? I will just have to like add one by one because um, we are not going to touch what works. Okay, so because I cannot modify the installation folder, which is strange because you could move it, right? Uh, yeah, you could just reinstall Unity. Yeah, I'll just remove Visual Studio Code. I'll just remove Visual Studio Community entirely. Which version of Panda do we get? Type passing. If 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 pandas is slower than NumPy, which is actually most, I mean, which is often the case, I think I will like have to downgrade my Python back to point 9. Wait, which one is which one is recommended? Um, I want to sleep. but I want to fix this bug first. So the next time, the next lab, we are going to work on it. Okay, so it's 3.9. Hold on. Is it conflicting each other right now? It looks like so. The wheel is still spinning. Um, I want to play this. Let me check. Okay, this thing is still on. So yeah. And now, where's the filter? Um, filter. Yeah, filters. Filters. And apply loop. Okay, we don't have loop. Mm, huh. Okay, so this one is finished. Okay. The Scikit. Oh, we have pandas. Pandas 1.5. Okay. Well, we know. Psychic. Oh, sci-fi. Yeah, we are looking for sci-fi now. Um, I cannot do. Where's the opacity? Color correction. And the color correction is where. Oh, what? The opacity is in color correction. This is strange. Very strange. Blend mode is necessary. Yeah, I can even change hue to like. I can. I mean, if I were, if I want, I can even run it by myself. I mean, I can set it to run by itself. What? Yeah. How about subtract? Looks good. Screen, multiply, darken. Yeah. Lighten. Attitude. I think it. I think this thing reacts to the music too. That's why you see. Wait. Wait. What? Ignore following versions that requires a different Python version. Less than 10. Verify version that satisfy SciPy. Hold on. Yeah, I'm still here. I'm just reading books. What is it? Tosh? Hold on, Tosh? Wait, Tosh plus Cuda? Hold on, Tosh plus Cuda is not normal. Um, and we need Cuda. Uh, um, I'm getting sleepy. Hold on. Oh, so hold on. So PyTorch supports Cuda now. Okay. Um, First of all, yeah, I think that's about it. This should this, this better work. This better work. I want to sleep now. I will conclude the lab today that um, we just yeah I will conclude this session as a pre-lab requirement, and I will work out about the installation later. I think basically I just need to re reinstall Python 3.9 to solve every problem. Uh, anyway, just turn the BGM off. Yeah, abruptly, abruptly. Now let's go. Yeah, yeah. The BGM is still there. I mean, I bring it back. Anyway, I think it's probably a good time to go to bed, and it's just like on my back. Um, I don't have anything to say other than see you later.